Hello everyone. I hope I'm audible. Okay. I'm Pranav. I'm here to give you an overview of the Voice Tech for All challenge, and showcase how we took this from a concept to a real-world initiative. At the core of the challenge, we proposed the following problem statement. Develop an advanced multi-speaker, multilingual text-to-speech synthesizer that supports accent and style transfer through zero-shot voice cloning, with a strong focus on efficiency, scalability, and output quality. To break this down, the model must be capable of multilingual. Capable, meaning the synthesizer should be able to synthesize audio from multiple languages. It also must be multi-speaker capable, meaning generating speech for multiple speakers. To achieve this multi-speaker capability, the system must employ zero-shot voice cloning, where the model is given a single speech utterance from an unknown speaker and must accurately mimic the speaker's vocal characteristics, including tone, accent, style, etc. To simplify this further, here is a demonstration of the system that we are looking for. The image at the center is the model, which takes in two inputs. One, the text, and the reference audio. The reference audio sounds something like this.
ఇది సాధారణంగా పరిగణించబడుతుంది 2 అయితే మీరు చెప్పినట్లుగా కళ్ళు
With the combination of these two inputs, here is the expected output.
ఇచ్చిన సందర్భంలో 2 గర్భధారణల మధ్య.
Here is another example of the same. Here we have Hindi text and a Hindi reference audio, which sounds like this.
अंडर ग्रिप यह मैन्यूवर यूटेरस के ऊपर वाले हिस्से को महसूस.
And here is the expected output.
पहली तिमाही में एरी जांच की जानी चाहिए.
So in essence, the model must generate synthetic speech for every. So in essence, the model must generate synthetic speech from a single previously unseen utterance and does so for across multiple languages. The languages selected for this task are Kannada, Hindi, Bengali, Marathi, Telugu, Bhojpuri, Magadhi, Chhattisgarhi, Maithili, English, and Gujarati.
Can you show me the sample for a Kannada?
We will be getting to those. So the next question is, how do we create an initiative that achieves this? We addressed this by defining 5 key components that form the foundation of the challenge. They are: attract a diverse set of capable teams, provide data sets to them, release a baseline and provide a structured challenge, define criteria for evaluating these models, and offer some meaningful awards to help motivate the teams. To reach a diverse and talented pool of participants, we collaborated with Next Chapter Studios. And with their help, we ran advertising campaigns across platforms such as LinkedIn and Twitter to spread awareness and invite participants. In addition to digital reach outs, we also engaged directly with the potential teams in person. Finally, we amplified our outreach through our collaborators Bhashini, GIZ, and Arman, whose network helped us connect with researchers, startups, and academic teams across ecosystems. As a result of our marketing efforts, we achieved over 400 registrations spanning 21 states and union territories. These participants represent a highly diverse range of professionals, academics, and cultural backgrounds. To ensure all participants share a clear understanding of the problem statement and to clarify any questions the teams may have about the finer technical and logistical details of the challenge. We conducted an introductory webinar on the 15th of November 2025. This session lasted close to 1 hour, including a dedicated Q&A segment, allowing participants to clarify any doubts that they may have and align their understanding with the challenge's expectations. This webinar had over 150 attendees who joined the session live. To ensure accessibility for those who were not able to attend these online event, we shared a recording of this webinar via email and also made it available on the Voice Tech for All website. That concludes the first element of the challenge. Moving on. Now that we have successfully attracted a diverse and capable set of teams, the next step was to provide high quality data sets to help them train their models. The data sets in question are Cispin and Spike core data sets. For those interested in learning more about these data sets, or for anyone planning to use them for their own projects, we have included 2 QR codes. The links, these link to the Spire datasets website and the Cispin webpage of the AI Coach website. We have diverse sets of teams, and we've provided these teams with high-quality datasets to build and train their models. So our next goal is to release a baseline that establishes a minimum performance bar and design a challenge track to ensure the teams exceed it. The challenge was structured into 2 rounds. Round 1 was an online phase, during which teams were required to submit APIs of their models built in accordance to certain specifications that we had provided them beforehand. And based on their submissions, we would shortlist teams to advance to round 2. Round 2 was an offline event, which brings us to today. Following a rigorous evaluation process conducted by an experienced jury of domain experts, we then select the winning teams. Here to talk about the baseline and the nuances of the challenge, my colleague Jesuraj.
Thank you, Pranav. Hello, everyone. I am Jesuraj, so I'll be continuing the presentation. Starting with the baseline that we released. So we trained the Your TTS, a multi-speaker, multilingual TTS model with zero-shot voice conversion capability. We trained it on complete Cispin and Spike core datasets about which we already discussed. And we open sourced this model along with the training and testing code base. And we also open sourced the script required to run an API endpoint because that's how we ran our inference. So the participants were supposed to host API endpoint, and we would run our inference script to get the synthesized audio. And we provided the code for the API as well, so that it helps the participants. Okay, so next we move on to team selection process. Yeah, so this is the overall flow of how round 1 happened, basically. The participants submitted the API endpoint and technical write-up for their system using a Google form. We ran inference on a test set using the API endpoint provided by the participants. To evaluate the quality of the synthesized audio, we used objective metrics. So after using these objective metrics, we shortlisted 10 participants, and the audios of these 10 participants were then sent for subjective evaluation. So I'll explain what these objective and subjective metrics are in the next slides. But overall, we use these 2 different sets of metrics and finally compile the results by averaging the scores across all metrics and shortlist teams for round 2, which is today. Yeah, so another thing is for shortlisting, in addition to these metrics I just talked about, we ensured that the submission followed certain guidelines. These guidelines included these API standards, uploading the code base to Hugging Face, by which these models and training and testing script can be open source. And then, like I mentioned, the participants were supposed to submit a technical write-up as well. So, yeah, so this is the exact workflow, which will go into details. So the first thing was if the submissions comply with the guidelines. So based on that, we had to shortlist the teams. If the submission did not follow, we had to reject, because the guidelines were very clear from right from the start. So once we received the API endpoints, we ran our inference scripts, and we received all the synthesized audios. So, like I said, there are two sets of metrics. First one is the objective metrics. For objective metrics, we used an ASR system to generate text from the synthesized audios, and then we compared these generated text with the input text, and got a score which we call word error rate. Then the other objective metric was speaker similarity score, where we used a speaker embedding model to get embeddings for both the reference and the synthesized audio, and we compare these embeddings to get a speaker similarity score. So for the subjective scoring, we use mean opinion score. Basically, what we do is we take all these synthesized audios and give it to experts who rate the quality of the audio on a scale of 1 to 5. And we used all these metrics to get final score by averaging it across all the metrics. And so for round 2, we selected top 4 teams, and they're all here today. Yeah, so these are the finalists. And yeah, for round 2, the evaluation process more or less remains the same objective and subjective scores. But in addition, we have something called jury evaluation. So in this, we have a jury of experts in the domain of speech technology who will evaluate the submissions on 5 different aspects. So the aspects are technical write-up, which is basically how well the methodology is explained in the write-up. Second is technical novelty, which is basically how novel the idea is. Then the quality of synthesized speech. Next is Q&A performance, so how well can the participants answer the questions that are asked to them by the jury. And the last one is poster presentation. These jury scores will be included in the final selection of winners, and the final ranking will be decided based on average ranking across all these metrics. So next, I'll be playing some of the sample audios we received from the 4 teams. I'll also be showing the text and the reference audio that we provided. So the reference audio and the text will not be the same utterance, but we expect the output to have the same text and the speech quality and speech characteristics of the reference speaker.
నడుము నొప్పి తీవ్రమైనదిగా ఉంటే లేదా రక్తస్రావం జ్వరం లేదా ఇతర అసాధారణ.
Okay, so this was the reference audio, and the text input can be seen. So
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చరా.
Okay, so this was the synthesized audio by the model submitted by CDAC. Yeah, also we have chopped the audio for 5 seconds. This is not the complete audio.
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో ఎర్ర రక్త కణాల.
Yeah, this is from Inverse AI.
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో ఎర్ర రక్త కణాల
This is from LTSC and
అనీమియా అనేది శరీరానికి అవసరమైన జీవక్రియ అవసరాలను తీర్చడంలో
yeah, so this was from Soumya AI. So you could notice that it's for the same text and same reference audio. There have been different characteristics that have been captured by these systems. It may be speaking rate or their pitch or the way the reference speaker speaks or the accent. So there are multiple attributes that we would want the model to capture, and these final models have done pretty good job. Okay. Because of the timing for presentation, I had to chop it for 5 seconds. We don't have Kannada in the presentation, so we'll share it later. Yeah. Okay, so now moving on to awards and prizes. Yeah, so to provide motivation to all the participants, we have very exciting prizes, as you can see. Okay, so I would like to thank everyone without whom this event would not be possible. I thank Bhashini for enhancing visibility of this challenge, IISc for providing background support for executing the challenge, GIZ for financial support, Art Park for providing team support and program management, and finally Arman for collaborating on defining the problem statement for the challenge. Thank you, everyone. And I guess we have time for Q&A. Yeah. If you guys have any questions.
So what was the volume or size of the test set that you used to evaluate?
So we had around 1,000 utterances for the test set. I don't think I can go into details about how many speakers we evaluated over, but yeah, it was about 1,000 utterances in the test set. No, test set is not public. That is the, yeah. Yeah. We had to pick one subjective evaluation metric, so we just went with MOS because previously in challenges with this data set, we had done a similar evaluation and it worked well for us in terms of judging the model, so that's what we went with. But that's something we could explore in the next challenge.
The MOS scores will be higher.
Okay.
For the synthesized voice than for the...
Okay.
So it's always, you should do degradation MOS.
So the user bias, you mean, basically?
User bias will go away when you...
Okay. I guess that's a very valid point. Although we did provide these instructions that you're supposed to score it just based on the quality and using the reference speaker characteristics, but that's a valid point. I believe in the next challenge we would look into it.
So the question is, like, we already have some of the Indian government recognized players like AI for Bharat and Sarvam, which is like basically from IIT Madras, I think what I heard. So, and then when I see here, you initially claimed that we are going to be open source, like even the form which we filled initially, all the players, all the top finalists, you are going to make it as open source.
Yeah.
Both their models, data sets. I think data sets also you want to make it?
If it's a closed data set, they are supposed to mention it, but if it's open data set, we mostly took information about the data set used, is what I believe.
So my question is, because see, if you look at AI for Bharat and those IIT Madras Research Park offerings, right? So what level do you think, suppose if you make all the data sets, at least the models, forget about data sets, at least the models, if you make it open source, Do you think like there's a competitive spirit or there's a collaborative spirit which you plan to see in the near future?
My opinion at least is, and from working on the data set and the challenge itself. Can you, yeah.
And then there is the third player which is Bharat Gen from Professor Ganesh, which is coming from IIT Bombay. So the question still remains same, that what is the convergence? Are we looking at something which is converging all these three, or it's a competitive spirit that we want to be better than Bharat Gen and Sarvam/AI for Bharat?
I don't think, at least speaking in with the perspective from the lab and what we believe in, we mostly are trying to open source most of the data set and models. So our goal is to collaborate and build technology that is accessible to everyone. So at least that is what our vision is. And in terms of the different labs and different companies collecting data, so one of the important things that makes our data unique is the sentences or utterances that we have are from different domains, and we have these domain specific sentences. That is, I think, one of the important things of CISPIN and Spire data set. And I think Professor would explain more about this.
I think that's a good question in the current context, the way various efforts are being taken into creating open source data sets, right? But I think we should look back a little bit in the history. So here Professor Hemamurthy is here. She has been leading. She has led a number of consortium projects in the past. But if you look back, let's say even 5 years before, right? There have been a lot of effort being put in, but it has really intensified in the last 5 years. So at this moment, at this juncture, it's very important to think the way you are asking the question, that whether it will be collaborative or competitive. And I mean, in the beginning, when there is very little things, let it be collaborative, let it be competitive, let something come out is the approach. But now going forward, I think we should certainly sit together, discuss, and then see whatever we create, they together becomes valuable, not something repetitive, right? And we have discussed that with Professor Mitesh, Hema, Umesh, everybody. And I think when we write the upcoming proposal, and that's where this consortium project really helps, as IIT Madras is leading now also, and I'm part of that too, where we really distribute the work so that multiple people do not end up doing the same. So thanks for the suggestion and thoughts, and we are indeed thinking.
So because I always feel that while you are saying that there's a consortium, but I always feel that there should be a competitive spirit, because unless that is there, if it's always a collaborative, people will not excel. So I think everybody is recognized nowadays that Ashwini Vaishnav recently launched the list, right? Where so I think all the players are there, but still, unless the everybody got the funding also. They have got, I think, pretty much. You also must have got the GPU allocation. So every player, IISc Bangalore, IIIT, everybody is getting the GPU allocation officially from the government of India. But still, what I believe is that there has to be some edge that we want to be at the top. Only then we will be able to. For that, I don't know, because even Sarvam and other players are keeping some of them as open source, some of them as non-open source, like some of them as like proprietary. So I just wanted to ask you, right, that do you really think that keeping everything open source is going to make sense? Because then you are literally not, keeping the margin for,
Let Hema comment.
Yeah. Who that was who asked the question. I think since I lead this consortium, I can tell you that Indian languages, there are not too many players. And the fact that all of us speak only in English and not in our native mother tongue. How many of us even write in our mother tongue is a question. The question is, if we really want this technology to reach the people who are one step, a delta function below us, we cannot do anything but put it in open source. Once you start pricing the technology, data and software, the last mile reachability almost is completely zero. So that is why it has to be open source for a while. And in the Indian context, this is something that we really need to worry about. I agree that the Sarvams, the IIT Madras stuff, and Mitesh Kapra and all, we have had the benefit of CDAC resources. There's one very big disappointment for me as consortium leader, that we have really not focused on the Indian ethos or Indian ecosystem, where we should be building very small footprint systems. We can neither afford the energy nor the GPUs that we want. Again, that's going to marginalize. In fact, I would have liked that you had something on footprint of the TTS systems. That what is the size of the footprint? It cannot be that I'm training for 40 days on GPUs provided by CDAC. It has to be trained much smaller footprint. And I think we could do it and we can do it, and this is something which I feel will be the driving force. I don't know how many of you know Qualcomm, Samsung, all of them are investing on edge devices which can do a lot of the stuff for us. Copying the West, riding on, in fact, riding on wits and riding on, I don't think is the correct way to go about it. I mean, but we had to start somewhere. We have started in the last 5-6 years. We made some progress, and the consortium was formed primarily getting all the people across India who is who in a particular technology, put things together. Maybe the future will start getting better for us.
Yeah. Mine was a very generic thing. After seeing that, text to voice kind of thing. Just imagine a hypothetical case where a small text portion is there which is written in English, where we have a challenger like RAMA. And we don't know the context and this one. The same RAMA is, it could be feminine or masculine. Rama or a Rama kind of thing. Then how do we, in such a, it's a very simple example. How do we judge, saying that is one, whether it's Rama or a Rama for a simple RAMA?
So, generally for TTS systems, in terms of how the pronunciation is and the word that is said, we use word error rate. Basically, we take the audio, give it to a speech recognition system, it generates text, and we compare the text. So
No, what I am telling is a text to the voice.
Yeah. So when you have this TTS system, you give it text like RAMA, it generates either Rama or Rama, right? So one of the ways we evaluate it is we have this speech recognition system, we give this audio, and that model will transcribe it. It will write the text for this audio. Yeah. So when there is this pronunciation changes, right? If the speech recognition model is good enough, it will transcribe it as RAMA. That is one of the things that the TTS models are evaluated with. And
the system gets some kind of hint.
Give the text in UTF-8, whether Rama and Rama will be key.
Okay.
Give the text in UTF-8. For example, I will write it in Tamil, I will write it in Telugu, I will write it in Kannada. So that problem will not be there. Only what happens is when you do speech-to-speech translation, the machine translation systems make a big mistake in gender.
Yeah, that's what.
During translation, it always assumes that the gender is male. This is a problem that we have. But not in TTS or in ASR. In speech recognition and synthesis, this problem will not be there because you're giving the text in the Indian language.
Yes.
That will not be a problem.
If the
problem is text-to-text translation. That's where it messes with the gender in a very big way. Because when you say avaru, for example, are we meaning woman or man? But it will say man in the translation.
Why so?
The reason is because we are trained with a lot of data from men. That's the problem. There's a bias in the machine translation system.
Anyway.
Yeah.
Yes, sir. So, what type of RAG applications
I think
are you being?
we'll take these questions offline during the break. Yeah. Yeah, thank you, Jesuraj and Pawan, for giving us the glimpse into the sheer amount of work behind this hackathon. May I now invite Nihar to give a small token of appreciation to both of this. We'll now break for tea and coffee, followed by poster presentations in the corridor. And from 1 to 2, we have a lunch break.